Once you know the sum and the difference identities and how to use them, the double angle identities springboard off of those. I'm going to show you where they come from. Fairly simple derivation for those. The double angle identities say basically what if A equals B in those identities. So for instance, for the sine of A plus B, which I already know is the sine of A times the cos of B plus the cos of A times the sine of B. What if A equals B? What if it's a double angle? What if it's the same angle, A and B? Then what I'm going to do is replace B with A and substitute. So instead of saying A plus B, I'm going to say A plus A. So I would put sine of A, cos of A, plus cos of A, sine of A, because it's the same angle. So whether that angle is 30 degrees or 60 degrees or whatever, it's going to be the same angle. That gives me the sine of 2A, twice A. Now in a graph, that's called my frequency. Ha! So this is going to be equal to, now look, I have a sine A cos A, and I essentially have a sine A cos A if I just rearrange the order of those terms. And again, multiplication's commutative, so it's okay to do that. I have like terms, it's twice the sine of A times the cos of A. And this is the double angle identity for sine. Doesn't make sense to do the difference of two angles if the angles are the same, because A minus A is 0. I already know the sign is 0, 0. So we're only looking at the sum here. All right, so there we have the double angle identity for sine. Sine of 2A is twice the sine of A times the cos of A. And yes, this is on the reference sheet for the final exam. So now let's look at the cosine for the sum. The cosine for the sum of two angles, I know from previous working, if you will, that the cos of A plus B is the cos of A times the cos of B minus the sine of A times the sine of B. But if A equals B, then it would be the cosine of A plus A again, and that would be the cos of A times the cos of A minus the sine of A times the sine of A. And so the way we write a cosine times itself is to put the square over the function in front of the angle like that. That way we know we're squaring the cosine of A and we're not squaring angle A. So cos A times cos A becomes cos squared A minus sine A times sine A is sine squared A. And that is the identity for the cosine of the double angle. Okay. What I'm going to do now is manipulate that into two other versions, because I also learned about the Pythagorean identities, and the Pythagorean identities allow me to substitute for sine squared of A or for cos squared of A. So let me take you to the next screen. Okay, so here's your Pythagorean identity, the main identity, sine squared A plus cos squared A equals 1. I can manipulate this by moving terms around, and I can actually create different versions of it, if you will. So if I choose to, I could actually solve this for the sine squared of A by taking cosine out and moving it to the other side with a subtraction. Okay? And then I would pull that plus sign out of there. So sine squared of A would be equal to 1 minus cosine squared of A. And I can write that. Sine squared of A equals 1 minus cosine squared of A. Because remember, when you go across an equal sign, it just changes the sign. Okay, let me start again. So I'm back to my original, sine squared a plus cos squared a equals 1. And this time I'm going to solve it for cos squared of a by moving the sine squared over. I'm going to subtract sine squared from both sides. And what I'll end up with is, boom, take that out, put that in. And so I can tell you that the cos squared of a is 1 minus sine squared of a. All of the Pythagorean identities can be manipulated this way. Okay, so I basically start with 1, and then I can form the other two. But the important thing is I can turn sine squared into cosine squared or cosine squared into sine squared anytime I want through this identity. What I'm going to do now is I'm going to use that Pythagorean identity, one of them, to substitute. I am going to take out my cos squared a, and I'm going to replace it with my 1 minus sine squared a from the previous stage of that identity. Cos squared a equals 1 minus sine squared a. And then I am going to pull this along for the ride and then clean it up. When I combine these, I get 1 minus, now these are like terms. I have 2 negative sine squared a's. So it's 1 minus 2 sine squared a. And this is a second version of the double angle identity for cosine. Similarly, I can take my original, which is cos squared a minus sine squared a, and I'm going to this time replace the sine squared a with its Pythagorean identity, which is 1 minus cos squared a. And again, those were on the previous page. Now what you got to be careful of here is this is cos squared a minus. So I need to distribute that negative to both of those terms. What I'm going to end up with is a cos squared a minus 1 plus, because I'm taking the negative of a negative, cos squared a. So I have 2 cos squared a's minus 1, and this is version number 3. So on the next page, I'm going to combine all those. So those are the 3 versions of the cosine of 2x, or the cosine for the double angle. You're going to pick one according to your needs, basically, which we will talk about in class, because I really just want to get the derivations into your notes. The last one, of course, is tangent, so let's go to the next stage. So just the way we did sine and cosine, we're going to take the tangent of a plus b. I put the identity back down, tan a plus tan b, over 1 minus tan a times tan b. And then we're saying, well, what if a equals b? Then it would be the tan of a plus a, which would give us tan a plus tan a over 1 minus tan a times tan a. And that's going to simplify. The tangent of twice a will be 2 times the tangent of a over 1 minus tangent squared a. It's minus. And this is your tangent identity. Okay, so you want to have those in your notes someplace easy to find, easy to reference. Sometimes I suggest that students start making a formula sheet in the back of their notebook. Of course, that helps if you actually have a single notebook for math where everything is together. The back page, the back 2 pages, the back cover of your notebook could be your formula sheet so that you have a go-to page where you know all your formulas sit. So, and when we get to class, we will look at these.